Hey guys, I am reporting from our home planet Earth in the Milky Way. But, as we all know, we're not alone here. Milky Way is home to at least 100 billion planets. Of those planets, 40 million of them are like our own planets. Now, ask yourself, what are the chances we are completely alone in our galaxy, the Milky Way? So, if 100 billion planets exist in the Milky Way alone, which is essentially one planet for each star, much like us and our moon, of these planets that are in the Milky Way, the question is how many can actually support life like we are on our planets? So, there's a term that scientists have come up with called the habitable zone, which is used to define what planets could possibly sustain life. So, to be considered a habitable planet, 3 requirements must be met. It must contain an abundance of chemical building blocks, liquid water must be present, and finally, an energy source to power chemical reactions. Earth meets all 3 of these, but during early Earth, our planet didn't meet any of these requirements at all. To estimate how many planets are habitable, in 1961, Professor Frank Drake presented a mathematical formula in order to estimate how many habitable planets might be in our solar system, the Milky Way, alone. This equation takes into account 8 different factors. Those 8 are the number of civilizations in the Milky Way whose electromagnetic emissions are detectable. Earth has electromagnetic fields around us, as well as we are producing radio signals to possibly other planets who may be able to pick those up. The rate of formation of stars that are suitable for the development of intelligent life, the fraction of those stars with planetary systems. So planetary systems are being formed each and every day. So only a fraction of those stars will actually form a solar system much like ours. The number of planets per solar system with an environment suitable to life. And the fraction of those suitable planets in which life actually appears, which is an unknown, and the fraction of life-bearing planets on which intelligent life emerges, the fraction of civilizations that develop technology that releases detectable signs of existence into space. Earth does that right now. The length of time it takes such civilizations to actually release those detectable signals into Earth. So we did not do that at the beginning of human life. We have only now, in our growth period, decided to try to find other life forms. And the current estimated number of habitable planets by this equation is 4,706. Mind you, that is in the Milky Way alone. There are many exoplanets as well outside of the Milky Way that may be suitable for life. So, in comparison to the Earth and other planets in their development stages. So, when Earth was young, Earth was formed 4.55 billion years ago. Early Earth is very reminiscent of planets that are already in our solar system. Early Earth was molten and completely inhospitable to life. It was just molten lava, molten rock. There was not any water at that point. So Earth cooled down about 3.8 billion years ago. And then life started forming soon afterwards. That is why having a something to power the chemical reactions, like a volcano, which early Earth definitely has, because we have today. It is very important because that begins life's formations along with these chemical building blocks. So it would be reasonable to assume that other planets would be similar to ours. Our planet cannot be completely alone in its formation. Early Earth may have won the jackpot for how quickly it formed life, but it would be reasonable to assume that other planets will be similar. But it wasn't until 200,000 years ago that humans evolved. Like, humans like us, Homo sapiens, evolved. We are the first, quote-unquote, intelligent life. We are broadcasting signals. We're wondering about other planets. So there are other planets that could have life, planets and stars of planets. So Mars could possibly have life. It contains chemical building blocks and energy sources because it is the red hot planet. It has plenty of volcanoes to form these chemical reactions, and liquid water once flowed there, as found by scientists, so there likely could be more water under the surface. Also, Jupiter's moon Europa is also very probable for a habitable planet, so it has a liquid ocean that is larger than Earth. The problem is Europa is covered in ice, so this liquid water is under several hundred miles of ice, and once that melts, then life is definitely possible. Saturn's moon, Euclides, has evidence of a warm ocean under its surface, which is covered mostly in land mass and rock. And there was molecular hydrogen found there, which is one of the main chemical building blocks. And finally, Jupiter's moon Titan. Its atmosphere is rich in organic compounds, and it is very thick. And this is really important because our thick atmosphere prevents us from dying of solar radiation. So could also sustain life. All of these, it may sound bizarre that like these very small things could then create life, but we have to realize that life is formed even in the most inhospitable of places. There is life under the ocean in hydrothermal vents, living in complete darkness, in unimaginable heat, and yet they still survive. Life lives on, even if it is very simple life, only a few cells. Multicellular life will come from just those single cells. So, in a nutshell, it's almost mathematically impossible for us to be alone. Our universe is forever expanding. We're only discovering more and more. And as we discover more, it seems irrational that we would be alone. There are millions and millions and millions of miles of space that we haven't explored. We haven't completely explored our entire galaxy. So, Neil deGrasse Tyson said that to declare Earth must be the only planet in the cosmos with life would be inexcusably egocentric of us. And I have to agree with him.